Good morning, all of you. Am I audible?
Yes, sir.
Oh, very nice. So let me start my presentation. Okay, we were in 8.1.1, 8.1.3. So in the last class, we were discussing with data intensive computing as well as the need of understanding distributed databases, how relational database was given importance in the earlier days. Now, because of the data intensive uh, computing and the large amount of data which is being flood to the processing, you need to think about a new technology, new era of data intensive computation. As we already said, there are multiple applications. There are scientific computing, there are social networking, social data, business data. Even Google is getting a lot of search engine data for mining and getting information, as well as Facebook and Twitter getting lot of information regarding inbox searching and other related operations. There is a need of development of data intensive computation. And we have seen in the previous class that what are the research avenues available for data intensive computation. What are the challenges available ahead for data intensive computation? Because the data is not in a standard format, data is in different type of format, that is heterogeneous data, structured data or unstructured data or semi-structured data. When it is a structured data, it is very easy to handle process, like we have understood in our traditional or legacy database management system. But in the case of semi-structured as well as unstructured data, the data will be saved in the form of large files. It cannot be stored in the form of relation database system. It should be saved in the form of data files. So how do we really handle such a large data file? What are the intricacies of handling such things need to be understood. So in this situation, we need to understand how this has evolved from the earlier database management system to the network of data. It is data which will be handled through the network. So there is a historical perspective on data handling. So in this 8.1.3, we would like to see historical perspective of data handling, the early age, high-speed wide area networking. As we already know, the data will be on the network, not in a single legacy system, single server, which will be keeping all the data and also the database server. And we will access the data from the database server to do some computation. But in the case of large data, it should be in the form of distributed environment. So in the distributed environment, the distributed servers need to be fed with the data, or the servers, data servers which are connected through the network need to be accessed from remote location. So in this scenario, you need to understand the importance of high-speed wide area networking. So in 1989, the first experiment in high-speed networking as a support for remote visualization of scientific data. The data is kept elsewhere, need to be accessed through the network. The TCP/IP based distributed application was also demonstrated at supercomputing in 1991. The further step was made by the Kaiser project, which made available as remote data sources, high data rate, and online instrument system. This is considered to be the wide area large data object WALDO system. That is wide area large data object system. So in this automatic generation of metadata was considered, automatic cataloging of data and metadata considered, facilitation of corporative research by funding, as well as providing local and remote user access to data has been considered. Distributed parallel storage system, as well as DARPA communication, as well as TerraVision also has been considered for this purpose. So mechanism to incorporate data into databases and other documents has been also considered in wide area large object model, large data object system. Next, main advantage of grid computing also has been taken into picture to handle large databases, large data sets. We call it as, now onwards we'll use a data set instead of databases, because the large data, it is not a database, it is a data set. So with the advent of grid computing, huge computational power as well as the storage facility could have been got by the grid computing has been taken as an advantage to store data, mine data, process data, discover data, transfer data, manipulate large data bases stored elsewhere in the distributed repositories. So the data stored in the various location, distributed location, has been taken, for handling data. So advent of grid computing has evolved the data handling very easily. Two main functionalities of data grid are high performance as well as highly reliable file transfer. The grid is something like, it's a standard connectivity where one-to-one connectivity or peer-to-peer connectivity has been established with a high-speed network. So the servers are connected, interconnected. The only management is how data need to be transferred to different locations, different servers at different locations, how data should be processed. Later, how do we get back the data from the remote location to the server location. Data grids mostly provide storage as well as data set management facility as support for scientific experiments. Remember, heterogeneity as well as security are the main concern for data grids. There is a picture given in figure 8.2 which tells the heterogeneity as well as robustness of grid computing. It is depicted in this picture. Let me go to that and then I'll come back to other slides. Just a minute. Okay, so in this picture, look at it. The picture tells you various connectivities as well as a data grid reference scenario with respect to whole world actually. Similarly, in India, we have a very highly reputed, highly structured grid computing platform, and also the cloud platform available for mainly Indian organizations are handling these grids. CDAC is the main company, which is the organization which is handling data grid for India. Okay, so data grid have their own characteristics as well as introducing new challenges. Among them, massive data sets is the one. The size of data set can easily be scale of gigabytes, terabytes, and also the beyond of that, petabytes. It is therefore necessary to minimize latencies during bulk transfer. Generally, when data transfer taken place in the network, you will have network delay, network latencies, the data transfer delay, the internet bandwidth problems. So you need to reduce and minimize latency for data transfer. So that is the main challenge in handling massive data sets. Bulk transfers replicate content with appropriate strategies as well as manage storage resources. So normally we have discussed in the previous classes also, when the data is being transferred to the remote location or the distributed location, the copy of the data will be sent. So when you are doing a copy of the data again and again, so the data, whether the data has been copied, the data has been modified or not, or it is data has been sent as a reference or data copy has been sent is also a question here. So mostly the data will be copied, no reference will be made. Even some modification in the data will not be taken back because only the data is sent for computation. Data, next one is shared data collection. Resource sharing includes a distributed collection of data. For example, repositories can be used for both storage as well as reading data. So maybe no writing will be there, but only reading data will be there from the location where it is available. Yesterday, we have seen another scenario. The computation power will go to the location where the data is available. Today, we are understanding grid computing here, data grid, where data will go to the location where the computing power is available. The next one is unified namespace. Data grids impose a unified local logical namespace where to locate data collection as well as resources. Every data element has a single logical name which is eventually mapped to different physical file names for the purpose of replication and accessibility. I can recall maybe in your database management system, when you have developed SQL queries for some data structure you have created or a database structure, a data table you have created user source name or system source name you have created. User source name will be there across all the database connectivity we are going to use it. So you have used open database connectivity using Oracle or SQL server you have connected. So if you recall that, you will understand. So JDBC, ODBC connectivity also you recall how you have given a source name. Similarly here also unified namespace or unified single name will be there, logical name will be there to locate data collections and resources, as well as the same namespace will be used for further logical name to access the same logical name from different locations. Access restriction is the next one. See, whenever you are creating data structure, data set, a database, you must have access permissions, access restrictions. It cannot be given to everyone. It cannot be a public data access. So data grid is to facilitate sharing of results as well as data for experiments. Some users may wish to ensure that confidential of their data is maintained. So you need to maintain confidentiality. You need to authenticate your users for access of data. So all these things are maintained in the restrictions. So allow access. You recall one more statement. When you are connecting to database, a MySQL database, you will be giving a statement like giving all privileges, give privileges to the database to all users, provide privileges. Recall it, just recall the statement which you have made for connecting to MySQL database. Maybe in your 7th semester laboratory also you are going to use that, provide privileges to certain users to access certain data. Same thing here also, So access restriction should be provided to ensure confidentiality, as well as authentication is required to authenticate data. Grids involve both coarse gain as well as fine grained access control over shared data connections. It is not to be used because there may be a chance that the remote server may be having access to unauthorized users. So when authentication is not there, then they may access, they steal the data. So the proper access restrictions must be provided to the distributed data sources. Okay, so we have seen this picture. Now we can recall it from the textbook. Also can see various facilities like scientific computing. Also they are using information discovery, also using storage facility they are providing. Okay, and there is a business site also, they may be using it. Instrument also they can use it. So all these are being shown in a different scenario to use that. Okay, next we will see some of the projects which have been listed in page number 8.5. Please refer to LHC grid, BIRN grid, that is a Bioinformatic Research Network, as well as International Virtual Observatory Alliance, IVOA. IVOA is another grid which have been listed here. Just go through them. These are all the data grids which are available currently. To understand more about it, go through data grid computing facilities. Next we have, how can we use cloud for data source as well as big data? Two important names you need to remember: data clouds or cloud-based data access, or big data. Large database, large data sets or database management have mostly been the domain for scientific computing. This scenario has recently changed because of massive data are being generated, produced, mined, crunched by companies providing internet services such as searching of data like Google, MSN, or doing lot of analysis on the search data. You have been knowing it. The search data is being ranked. Based on the search only, you will be getting your ranked pages. So whenever you are searching the most recently visited or highly sensitive data, and most people visited the data will be shown as the first data. That is by ranking the data. All these are being done with the advent of big data. Internet services are searching, online advertisements, and the social media. Because of this, enormous amount of data is being consumed, enormous amount of data is being produced. So once the data is produced, that should be mined, and based on the you need to analyze data and go with advertisements and business, because this is the business actually. So online advertisements will be generated based on the data mined. As you know already, because you have already used search engines for accessing your data. So normally, how do they do it? They access log files. Every day they do a petabyte of data is being processed in Google. They take log files accessed, using search access. It will be created. The log files are created. Enormous log files are created, and these log files are analyzed for accessing data. What is the trend of people? Okay, area-wise, country-wise, trend of people will be shown, and they will do analysis. Based on that, they will go with other type of advertisements as well as other accessing and showing the data. Similarly, another one is big data. So why do they call it as a big data? Big data is the term big data applies to data sets of size is beyond the ability of commonly used software tools to capture, manage, process within a tolerable elapsed time. It is a big data. Why they call it as big data? Data in the form of large amount of data which we cannot process. It cannot be work with the DBMS tool. It cannot be worked with the DBMS tool. Okay, so simple DBMS tool cannot go. So the data set that grow largely. When you are developing an application for a mobile service provider, just think over how many connections will be there at a time, how many people will be connecting each other, how much they are speaking, how much data is being consumed, how much data is being transmitted, how much data has been downloaded. So based on that, they can do analysis, they can do other type of, because how do they really manage? You may be understanding that they will give you 1.5 GB data per day. But do you really use that? How do they really reduce the speed? Suddenly you feel that, okay, after consuming 1 GB of data, some company may reduce the data speed. How do they really do it? So these are all the things which, realistically, in the real time, they will be analyzing. So this is what you need to understand. So for doing all this, they must have a proper infrastructure to handle distributed data. So the term big data applies to data sets of which the size is beyond the ability of commonly used software tools to capture, manage, and process within a tolerable elapsed time. Cloud technologies support data-intensive computing in several ways. By providing large amount of computing instances on demand that can be used to process and analyze large data sets in parallel. That's what we have discussed in 6th chapter, the parallel computing. By providing a storage system optimized for keeping large blobs of data. That's why Google uses big table. They call it as a big table. Amazon uses Amazon Elastic Cloud. So they have all these companies, they have got their own data structure, data management, how do the data files, how do they really handle these data? All these things will be discussed in the next coming classes onwards. By providing storage systems optimized for keeping large blocks of data and other distributed data stores in the data architectures, store architectures. By providing framework and programming API optimized for processing and management of data. So it has been listed here. By providing a large amount of compute instances on demand, which can be used to process and analyze large data sets in parallel. By providing a storage system optimized for keeping large blocks of data and other distributed data store architectures. By providing frameworks and programming APIs optimized for the processing and management of large amount of data. There are scenarios. Data cloud is a combination of 3 components. First example, MapReduce framework. We'll discuss in detail about this MapReduce framework. In the coming class, we'll discuss about this, which provides the best performance for leveraging Google file system on top of Google's large computing infrastructure. So the MapReduce framework, which is a programming environment, which has been provided by Google to do data processing, not the database processing, it's the data processing which has been underlying with the Google large computing infrastructure. Under the computing infrastructure of Google, GFS, Google File System, the MapReduce. It is very interesting to understand. You have large amount of data. Just I'll give you a glimpse, and we will understand this in the next hour. In the MapReduce, what is meant by mapping and reducing? You have large amount of data. There are heterogeneous or different types of data. The types of data may be string, character, integer, float, all that. That is a data type you can think of. We can take a small problem to understand this. You have large amount of data. Then quantity of data is large. You understand that. Amount of data is large. So take these data and segregate these data into pieces. And in that data, you have commonalities. You have commonalities. These commonalities can be taken into separate groups. So once this common data can be taken into a specific group, then the common data can be reduced. By increasing the number, the data, you can see, okay, so many data is available, so many data is available like that. So from the heterogeneous data, you try to make single tone data. And then, so from the mapping, you are reducing it. So this is where you are trying to manage the data in a proper way. Second one is Hadoop system. We'll elaborate the MapReduce framework, and also MapReduce with Aneka also has been discussed in the topic. We'll discuss more on that. Hadoop system. Next one is HDFS. The file system is named as Hadoop Distributed File System. Remember, when you are handling a file system in a single system, it's different compared to file system available in a distributed environment. Hadoop system, the most mature, large open source data cloud. It consists of Hadoop distributed file system, which is called as HDFS in short, and Hadoop's implementation of MapReduce. Here also they are using MapReduce, but it is Hadoop's implementation. We'll discuss this also in detail. The third one is considered to be a sector, which is a replacement or the alternative for MapReduce concept. Sector, which consists of sector distributed file system, which is also known as SDFS, and compute service called Sphere, that allows user to execute arbitrarily user-defined function. We call it as UDFs over a data managed by SDFS. Okay. So note these points. Next, finally, databases and data-intensive computing. Just now I have explained you, it is not possible to handle large amount of data using a traditional DBMS, because in the traditional DBMS, when we were handling the DBMS using the relational database management system. When we have discussed DBMS for a minute, let me go back to the DBMS topic. Database management system. How many types of database management systems were there? When we were discussing with the DBMS, the relational database management system, we could have three different types of database management system: hierarchical database management system as well as network database management system. Are you not thinking the distributed database management system or a distributed databases collection of data stored at different sites over a computer network? It is a network of databases, network of data. So now look at it. We were understanding this in the previous semester, that DBMS and the relation DBMS was the biggest one. Now you think about a big data where network of data sets are available. The network of data. Distributed data system show this in the networking environment. That's a network of data is being used. So as I told you, relation database management system was unable to handle large amount of data because it is unmanageable in a single system. It should be with a distributed environment. So a distributed database can be created by splitting and scattering the data of an existing database over different sites. This is what I was mentioning since the beginning. You need to segregate, you need to split the data into pieces, stored in a different location, in a different site. These systems are very robust and provide a distributed transaction processing, distributed query optimization, and efficient management of resources. So to do all this, you must have a proper infrastructure. You must have proper mechanism to handle distributed data sets. Whenever you should be able to get the data for computation. So data should be ready for computation. So you must have a mechanism to capture the data and feed the data for computation. All these are very, very interesting and very important to note. We need to concern about how relational model can be used to represent our data. How we need to enforce ACID properties, recall ACID properties in the databases, data limits, as well as in the data clouds as well as grids. So with this, I conclude my class. We'll go for a question answering session now. If you have any questions, please put your questions in the chat box. Let me answer. From the next class onwards, we will move on to 8.2 technologies for data intensive computing. In this, we will discuss about the storage systems, high performance distributed file systems, as well as storage clouds. In this, we will discuss various parallel processing systems, as well as file systems provided by various organizations like IBM General Parallel Processing, General Parallel File System, we call it as GPFS. Google File System, very interesting to understand. Google File System, GFS. We have another one is called Sector. It is a storage cloud supporting the execution of data intensive application defined according to the Sphere framework. Next one, we will understand Elastic Computing Cloud as well as Simple Storage Service S3. We call it as Amazon S3, Simple Storage Service. Interestingly, no SQL systems, not only SQL, because SQL was being used for DBMS. Now, not only SQL is there, so how do we really handle this? Apart from relational database systems, how NoSQL can be used for handling data sets. Next, we will discuss Apache Cloud DB or CouchDB as well as MongoDB. MongoDB you have already started working on. Some of you have already started working on MongoDB. So recall it. We will understand along with Google Bigtable, Apache Cassandra, Hadoop HBase. And finally, we will go with the MapReduce programming model. So all of you come prepared. You read these sections before coming to the next class from 8.7 to 8.14. Okay, we'll go through this in detail in the next step. Thank you. I'll go to the question answering session now.